Hello everyone. In this video, we're going to talk about how to integrate Cisco DNA controller in the NDB controller for span automation. Let's imagine you have a Cisco DNA controller and you're using NDB controller for the span automation. And if you don't have this integration, you have to go to the DNS controller and configure the local span on your catalyst switches. Again, come back to the NDB controller and configuring the tap aggregation policy and sending it to the tool ports. And it's going to be too much of redundant work for going screen by screen. To solve this problem statement, we have a integration in the NDB controller where the NDB controller can talk to the Cisco DNA controller for your span automation. Cisco DNA controller is a powerful controller to do the management for your campus networking. And what we can do is once the Cisco DNA controller is added to the NDB controller, it's going to automate all the span configurations directly from the NDB UI. And in order to do that, what exactly NDB does it creates a little project and a template when the DNAC is added, and this template is used every time for automating the span configuration on your catalyst switches. And also the way how NDB instructs the DNAC controller is using REST API calls. And it's not just with the DNAC controller, it also can integrate with Cisco ACI controller for which manages your Cisco data center and also your standalone NAND case. It's a single pane of glass which can manage all the span configuration on catalyst switches using DNAC controller, on the data center switches using Cisco ACI controller, and on the independent production switches using NX API plugin. So first let's see how to add a DNA controller to the NDB controller. For that we go to the span devices and the type of the controller should be selected as DNAC and give the IP address of the DNA controller, the username and the password and the DNAC name. And this name is used internally for configuring the configuration sessions on the catalyst switches. So next thing what we do is once after we add by supplying the IP address, username and the password, this starts showing up in the span devices. And after showing up on the span devices, now the DNAC controller is also seeing the NDB topology along with the other Nexus 9K switches on the tools. And as we spoke earlier, it creates a little template and the template can be clearly seen here, like the template which is used to create the sessions which have two types, which is the source interfaces and the destination interfaces. And this template is used to automate the configurations on the span sessions in the catalyst switches. And so once we create the span session, so this span session is nothing but a combination of the span sources and the span destination. The span sources and the span destination are automated on the catalyst switch using REST API calls by the NDB controller. And let's take a look at how the configurations will look like once the automation is complete. As you can see, NDB controller automated the span configurations on the catalyst switch. And now, once after stitching this two path together, so now the NDB controller went on the catalyst switch and automated the configuration. Now the copy traffic from catalyst switch is coming to the NDB. On the NDB switch, we configure a connection which is nothing but taking the copy traffic from the catalyst and then sending them to your tools that you like. In this example, it is sent to the Wireshark server for investigating the packets that are coming from your catalyst switch. So for this demonstration, the NDB controller that we used is 3.10.3 and also the DNA controller that we used is 2.3.5.5. And once after we create a connection, meaning once we get the raw packets from the catalyst, we create a connection and this particular connection is created on the Nexus 9K, which is an NDB switch in this case. And here is the software and the hardware that we use to do the tap aggregation policy. And here is the catalyst switch hardware and the software that we used for this demonstration. Here is a quick snapshot of the supported metrics, which is the NDB version, which is 3.10.3, and the DNAC version we used is 2.3.5.5, and the switch NXOS NDB switch hardware we used is C93108 TC-FX, and the NXOS version is 3.10.3. And the catalyst switch what we used is C9300-24U, and the iOS XE version we used is 17.13. Please note that not all the catalyst switches are supported and not all the iOS XEs are supported, and please take a look at the release notes and the configuration guide that are available on the NDB controller page to understand the supported catalyst switches and the supported iOS XE versions to do this integration.